I just wanted to make this LightSIDE tutorial for you to give you a little bit more insight into the process that you might use to get the most out of LightSIDE as a tool. So first, LightSIDE is one of a set of tools that you should probably have at your disposal. First, you should almost definitely buy this book. It's extremely helpful. It's the book that I use in my applied machine learning class. It tells you a lot of background information about the algorithms and how to think about the process of applying machine learning. It's written in a very accessible way. You don't have to have much exposure to machine learning before reading this book, and you should be able to grasp the main ideas. And having read it, you will be in a much better position to make use of LightSIDE. You can certainly use LightSIDE even without that background, but honestly, you can only get so far without spending a little bit of time getting to know the concepts. If you want to dig deeper, there are many other resources that you can get. And these days, many of these books that are listed on this slide here that you see, you can just download as PDFs from the internet or buy very cheaply from Amazon.com. So hopefully you can get a hold of these. And you'll see that there's quite a path ahead of you. You can start with very little background in machine learning, doing something practical, but there's always more to learn, and it can become a fun hobby. I think it's really interesting and really exciting. As for software tools, LightSIDE is the main tool bench that you'll use, but for the machine learning algorithms themselves, most of the ones that are inside of LightSIDE are also in an off-the-shelf tool called Weka that would also be good for you to have access to. It's the one that's used in the book that I pointed to earlier, and for all of the machine learning aspects, they're there. Now, what LightSIDE offers on top of that is the ability to extract useful predictive features from text, and it also lays out a pipeline that embodies my development methodology for building machine learning models. But there are still lots of resources inside of Weka that are useful to have access to. Also, you'll want to have some data manipulation tools at your disposal because ultimately you'll be getting data from lots of sources over time, and you often have to do some reformatting and cleaning up of that data before you start to run machine learning experiments on them. And so what you might want to do is get to know some kind of scripting language like R, Python, or Perl. All of these are available for download off the web along with some learning resources, so those should be accessible. But even if you just have some knowledge of how to use Excel, that will also go a long way for you. So you will download LightSIDE, and it should be fairly easy to install. Actually, you'll see here the URL for downloading the English version of LightSIDE. If you're using it for a different language like Chinese or Arabic, you'll want to get those sources from us. When you open up LightSIDE, you'll see this folder. It has some subfolders, and some of those you'll need to get to know later, like the data folder, the saved folder, and the toolkits folder. But mostly, the first thing that you want to see is the user's manual, because you'll want to read that fully before you start using LightSIDE and even before you listen to this lecture. Now, once you have installed LightSIDE, you've read the user's manual, you've tried to step through the tutorial that's in the user's manual, and now you're ready for a little bit more conceptual depth, more tools, and more direction. Now is the time to dig into the rest of the details in this lecture. So I'm going to start off by leading you through a little exercise to help you think about working with text. I'm going to advocate that before you run any machine learning experiments at all, you really get to know your data and you look at it and you try to notice some structure. And you wouldn't be using LightSIDE most likely if you weren't trying to do something with text, and it would be extremely helpful to get a little bit of background in linguistics or discourse analysis and to really look at the data and start to notice the details of what are the characteristics of text in one category or another, or that should be rated higher versus lower, that you would want the model to learn to notice. Because ultimately it's going to be up to you to configure LightSIDE to extract from the text those predictive variables that are embedded in the text. These extractors are like questions that are posed to the text. And so to set up for designing those questions, which will be formally little computer programs themselves, you should go through the process of acting like you're that computer program first. So that's what I'm going to allow you to do in this text teaser. So here you can see the kinds of choices that are required while you're setting up a model to do machine learning on text or really any kind of data. And so there are some things that you have to think about in terms of what kind of model you want to use or what kind of training algorithm. And so the first two options here, linear or nonlinear, statistical, weight-based, or symbolic, these are distinctions you would get to know if you read that book I pointed to. And these are things that you will indeed need to think through and make a choice about. But then you'll see feature extraction and selection. That's what I'm going to spend most of my time talking about in this lecture. And then there's also an area, protection against overfitting. And these are kinds of meta techniques that you can also learn about in that book and that are available both in Weka and in LightSIDE. Okay, so consider this very simple CSV file here. It says XLS, but in LightSIDE actually you want to have saved the file in CSV format before you load it. And this format that you see here with one column that has some labels and another column that has text is the very simple basic format of an input file for LightSIDE. You could also have additional columns. There would be other features that you could use in your model, and we'll talk about that later. But for now, let's do the simplest case, the case where you just have two columns. One has the text, the other has the label that you want to predict. And in this problem, what we're doing is we're looking at sentences and we're trying to distinguish between ones that are meant to be taken as a question and others that are meant to be taken as a statement. And so what I'd like you to do right now is pause this video and ask yourself, in these texts, what kinds of things do you see that distinguish these two categories? So hopefully you stopped and did that, and now you're back. And now I'm going to step you through what you might have noticed. So one thing is, many people, when they look at these texts, notice that punctuation is a good predictor of question versus statement, that oftentimes questions end with a question mark and statements end with a period. But here where you see marked in green are places where punctuation would make the prediction that we would want it to, but the ones that are circled in red are ones where they would make the wrong prediction. So sometimes there are sentences that look like statements, they end in a period, and nevertheless they are questions. And other times there's punctuation that's missing, and that can be an issue as well. Another thing that people notice is that the questions seem to be referring to another person using the word you, whereas the statements tend to be referring to the speaker, or say I or me. On the other hand, there were some examples in this data set where those pronouns are used the opposite way. Finally, people often notice that WH words, question words like what, where, which, tend to occur in questions more than they occur in statements. But sometimes a WH word is just used to link an embedded clause to a constituent in the main clause. Now, nevertheless, these features can come together. Oftentimes with text, we have multiple features, and together they compensate for each other's weaknesses. And there usually are not features that are very strong that by themselves could make the prediction that you want. And so you need large numbers of these features, and they might be what we would call noisy, each one. They don't always make the prediction you want. But at the same time, together, the evidence will point in the direction that you want. So the idea here is this. Those features, they're really important because the machine learning itself, the algorithm, can only do as well as the information or the clues that you provide to it. The machine learning itself isn't magic, but it can be very useful for identifying meaningful patterns in your data when used properly. But proper use requires insight into your data. And here's an example that I like to give as an illustration. Here's a bowl of colored candies. In the United States, kids like to play with these candies. We call them M&Ms, and they like to divide them into piles according to color. But imagine if you bleached the candy white before you asked a child to divide the candies into color-based piles. They wouldn't be able to do that. Even though it's a very easy task. The problem is that in bleaching the candy white, you removed the part of the signal that was necessary for doing the task. Similarly, we start out with texts, and we use feature extractors that are like questions of the text. These questions might be things like, what's the punctuation? Or are there WH words? Or does it say me, or does it say I? These things are indicators. Now, if we did a poor job and instead we picked indicators that are not very relevant and we left out those indicators that are related to what it is that we're trying to decide about each instance, or that we want the model that's trained to be able to distinguish between, it would be like bleaching the candy white. So we need to do a really careful job at that initial stage of working with our data to decide what the features should be. Now let's take a very quick tour of LightSIDE to get to know its features. Here's what you will see when you first start LightSIDE up. This is the Extract Features panel. Now, initially what you'll want to do is click on the folder icon that you see at the top. And when you do, you'll get this Finder menu, and it will take you directly to the data folder. And then you can click on a file that has some data in it. You'll see there are lots of options here. And if you have a file that has your data, you can just drop it into that data folder. The data folder is one of the folders you see when you unzip LightSIDE. If you're not using the English version of LightSIDE, you'll want to put in a file of data for the language you're working with. So if you're working with Chinese LightSIDE, then take a data set in CSV form that has Chinese data in text in one column and the labels in another, and drop it right into this data folder so that you can select it from the Extract Features panel very easily. But for this demo, I'm going to work with the English version. So I'm going to select the sentiment sentences data set. Okay. Then you'll want to make sure that what it has listed as the class value is the name of the column that has the labels that you want to predict. And you'll want to also make sure that the type is set to nominal if what you want to do is categorize your data. And then below that, you'll see what says text fields. You'll want to check a box next to the name of the column that has the text in it. If you have multiple columns of text and you want to extract features from all of them simultaneously, you'll want to check off all of them, and depending upon whether you want to consider it as all as one big piece of text, then you can leave it at the default. But if you want to distinguish between columns of different columns where the text comes from, then you'll want to click on Differentiate Text Fields. Now, By default, the basic feature extractors will be selected, and you should leave it at default for this initial playing around with LightSIDE, and it will also be configured to look for individual words called unigrams. And it's going to be configured so that when it extracts features, it's going to make them binary features, which means that the value of the feature will be true or false. Now, these features are like questions that are asked of the text, just as I said. So for unigrams, each one of the features is asking the text, is the word something in the text? So for every word that occurs in any text in your data set, it could potentially be one of the unigram features. So if there are 100 different words, then you might have 100 different features, one for each of those words. So if you had a word apple, then the apple feature extractor will ask every instance, every piece of data, does your text include the word apple? And if it does, then its value will be true for that data point. Otherwise, its value will be false for that data point. And that's what the unigram feature space is. So that's what you would be deciding in this next section of the interface. And later on in this couple of lectures that I'll give you on how to use LightSIDE, I'm going to talk to you about the other feature extractors, but we won't get there in this first introductory one. Okay, so the next thing you want to do is extract those features. And you'll see here a couple of things. One of them is the rare threshold, and it's set to 5. What that means is that in going through your whole data set, instance by instance, each instance is a data point or a row in your CSV file, it's going to see for every feature that it's trying to extract how many of them have value true. If fewer than 5 out of the whole set have value true, then it's going to throw away that feature because it only wants ones that are around a certain number of times so that a stable pattern with that feature can be found. You can also name the feature set that you're extracting because you can extract more than one under different configurations. And you'll want to be able to find them in pull-down menus. So then you'll want to give each one a name that you can remember. Once this is all configured and you're ready, then you will click the Extract button. And when you do, then you'll see the list of features that were extracted in the lower right-hand corner. If you want to save your feature space, you can click on this floppy disk icon, and you can actually save the data set in its extracted form in the format that you could load into the Weka toolkit, and that would be to save it with the file format ARFF. You can see here how you can set that file format. Okay, once you have extracted your feature space, then you can run an experiment using the Build Models panel. Now, when you get to the Build Models panel, the first thing you'll do is use the pull-down menu on the left-hand side to select which feature space you want. So that's why it was a good idea to name each feature space that you extracted a name that will allow you to remember what was the configuration. And then next, you're going to pick out what algorithm you want to use for your experiment. Now, what I recommend for text is that you use logistic regression. Default is naive Bayes, but logistic regression is better for a number of reasons. One is that it sets you up better to do an error analysis in LightSIDE. Another one is that it's very effective for text categorization. It's very effective at being able to identify which features are more useful than others and to teach itself kind of how to ignore those features that are just going to get in the way of doing an accurate classification. You'll see below the Learning plugin some test options as well. You'll want to leave it for now on cross-validation, and you can find out more about cross-validation from some other supplementary videos. Okay, then you'll see here you can name your experiment, and you might want to do that if you're going to want to compare the results across multiple runs. And you also get to decide if you want to use feature selection. Feature selection is a way of narrowing down your set of features to the most promising looking ones before you actually do the model building. But actually, I suggest you don't worry about that yet. Now, when you want to run your experiment, you click the train button, and then you'll see the results below. You'll see, first of all, accuracy and kappa. These will tell you a little bit about how well the experiment went. Accuracy is just the percentage of instances that were classified correctly. Kappa is an adjustment on that where the model doesn't get credit or as much credit for being correct on examples of categories that occur very frequently. It gets more credit for those that occur less frequently. Because even if it was just guessing, it could get a lot of the ones that occur very commonly correct. We're not going to talk in great detail about kappa, but there are a lot of online resources. So, something that's important to note here is the confusion matrix, and it tells you in the columns what was predicted, and in the rows what should have been predicted. So if you look at the cell that's in the upper left-hand corner here, these were things that were hand labeled as negative and the model predicted it as negative. Next to that, we have the number that were actually negative by the hand codes, but the model predicted it as positive. So these were incorrectly classified. In the second row, we have positive examples. These are ones that were hand labeled as positive. In the first cell, we have those that were positive, but the model labeled them as negative. So these were incorrectly classified. And then finally, we have those that were positive, and the model correctly predicted that they were positive. Okay, in our next lecture, we're going to move on to talking about what kind of development process would be effective in LightSIDE. But for now, I suggest that you make sure that you're able to replicate the process that I stepped through in the very small demo that I just showed. And we'll come back and go further a little bit later.